Welcome Park Facebook group for today's tip of the day. It will be on the HydroClear and how to optimize that. Before we get started, we're going to talk a little bit about masks. Today with Matt Groh is here with us. We will have our masks off, but we will maintain 6 feet of social distance so you can hear us well. Again, I have Matt Groh, one of our project mechanical engineers, one of our experts on a handful of machines. HydroClear. 1, the theory of operation, the basics of just how does it work. 2, and 3, we're going to do a little science experiment, which will bring that all together into how you can optimize that machine. Matt, why don't you start off? Welcome, and we're glad to have you here.
Thank you, Joe. All right, first thing I want to cover is some of the theory, like Joe said, and I want to talk about some of the basic operating principles and hopefully give you an idea as to how the chemistry works, because it's really not that much magic. So I want to help you understand that, and I think that after you understand a bit about what the theory is, I think that'll help you in your shop and get you running more efficiently and smoothly, better with some better water. So
before you jump into that, Matt, I just want to remind everybody, I forgot to in the opening, if you have questions, please ask them in the comments. We'll take them questions real time, probably be able to answer them, or Matt will. If not, we'll be able to get back to you after we do a little research. Thanks, Matt.
Yeah. So this will be quick, but it's important that you understand this. So what I'm going to do is I'm going to draw out a basic system and identify some of the points that we have. And this is typical for 99.99% of shops. Everybody has a pit where they collect water. From there, they have to get their water out. They pump it out. Send it somewhere. In this case, we're talking about HydroClear. So let's draw that in here too, just for fun. So when it comes to the chemicals and how we get them in the system, that comes on 2 fronts. The first is the coagulant chemical. We inject that right out of the pit. If we could get any closer, we would. But the reason that we do that is so that we get good mixing as the slurry water is on its way into the HydroClear tower. Past that, for people who have a second stage chemical, which I'll talk about why you would want that in a little bit, we inject that later. This is a very deliberate process in the way that we inject coagulant. I'm just going to put coag there for sure, and flocculant at the top. What's happening here is we're injecting the coagulant on purpose, and here's what's happening when we're doing that. Let's take a column of water, and we're going to fill it all up with suspended solids, big ones, little ones, tiny ones, and we need these to settle out somehow. So what we're going to do first is we're going to add in the coagulant. And what that's going to do is that's going to allow all these little particles to collide. Naturally, the particles are negatively charged. What that means is that they want to repel each other. If you've ever taken a glass full of slurry water, I don't know how many of you have probably done that, but you'll notice that the slurry water stays in suspension. You get a lot that settles to the bottom, but you see a lot that's suspended and it just hangs there. And that is due to these negative charges keeping all of those particles apart. So what we're doing with coagulant when we introduce that is we're neutralizing. I'm making up chemistry symbols here. This is my neutralized symbol, squiggly. And what this transforms into is the beginning of flocculation. Now these are neutralized. Now they can collide, and they're going to form a little bit bigger flocks. We didn't add flocculant yet, but just that little bit of allowing them to collide together already makes them bigger. Now these are larger, they're heavier, and they will settle out faster. Okay? Now, this is good enough for probably half the shops out there. Many people are happy, they're okay with having a little bit cloudy water, a little bit turbid. For others that demand a little bit better, if it just helps you sleep at night a little bit more, or if you're concerned about a good polish, perhaps you have a machine that might require it. we can introduce flocculant in here. Previously flocculant, I took the approach of if you didn't need it and you don't want it, then don't do it. I've since changed up a little bit because we've worked with some chemists and some water specialists that have adopted that, and this is a much more robust, easy to use chemical. So here's what happens. Here's what happens when we add in the flocculant. Here's your column of water again. We inject this up here, and now what's actually happening is the flocculant is forming polymer bonds between these. So now these are even larger. In fact, when I demonstrate to you what it looks like physically, you're going to see these look a little fuzzy. So these are now even larger, and they settle out even more rapidly and give you a clearer water that's not quite as turbulent. So we have this exact system, much like many of you do in your shop. So I want to show you the way that we have this. So we're going to walk over to our training center HydroClear system. Come along. Now we have two tanks. We have a coagulant tank and we have our flocculant tank. You'll notice on these that they are labeled, and I'm going to tell you why that's important later. We have coagulant here, flocculant here, and I want you to notice that just like I drew out, I have the injection port here. This is purposefully easy to take off. It's just a ferrule nut that you can take off if you need to. I'll tell you why that's important in a bit. But you can see coagulant injected here, coming right out of our pit, followed by our flocculant line coming out. So mix with coagulant, then our flocculant at the top, and the recipe for our clarifier. So I'm going to show you guys a little bit of what this looks like physically, because let's go back over to my table here. I have, in my experience with these systems, one of the things that's helped me the greatest is developing an eye for what settled out particles look like, what clarified water should look like. And over a short period of time, I've picked up on that and developed my own senses of sight to have it optimized. I want to give you that same idea so that when you take a sample of your water, you can do that too. So what we're going to do is I'm going to take raw slurry that we pulled out of the trenches here. This is some excellent stuff. Probably looks very familiar to a lot of you. And I am going to dose this in the same manner that our system doses it.
Hey Matt, while you're getting that ready, we did have a question. We had a customer comment that previously they had one system. They were able to keep the water clear, really nice.
Yeah.
Now they have two systems and they're just struggling. So maybe it's a good time to answer that, or maybe at the end you'll circle back and be able to answer that with a parallel system, dare I say, or two systems. But sounds like something pretty simple.
Yeah. That's not uncommon. So people that have two systems, it's not extremely rare. It's not unheard of for people that have it. But the people who succeed with two separate systems, like we have here, two of these systems, they work the best when they're completely independent, because we are dosing chemicals at a very specific rate. And if one system takes a little bit more and takes a little bit less, and you combine that, which I'm sure that I'm not sure, but it's likely that those are being combined in the end, it's very difficult to tune them separately. But it has been done, and there are a number of things that you can do to help that out. Things like using one slurry pump to draw your water, and then collecting it all in one area. Really, just splitting up the clarifying isn't terrible. But oftentimes, when one system is older, just that system being dirty alone can make all the difference. You've heard from our service people that we recommend that you clean these every 12 months. Some people elect to do it every 8 because they like their water to be perfect. So yeah. So did I get that?
In the comments, our question asker said that is how they have theirs set up as an individual system. So maybe you need a little bit more detail, more than we can get through with the comments. If that's the case, we can recommend you call customer service or call your sales consultant, and we can kind of dive into them details a little further. If you do have a few more tips, knowing that they have it set up individualized, absolutely fire away.
Yeah. So if you have one system that's not performing like the other, first off, I'm gonna say to call customer service. But before that upsets you, that would upset me if somebody told me that. Have this information ready. Let them know how old that system is. Let them know have your chemical settings ready, and also advise them what the difference is on those two slurries. If they are indeed the same systems, then it shouldn't be that hard to diagnose. And I work very closely with our service department, and so if they have something where they're troubleshooting and if it's not quite making sense, they'll get on the phone right to me, and we'll do it. I've done a lot of that and happy to do it. I actually enjoy it. Kind of a Bobby Boucher water nerd. So hopefully we can help you out. All right, so all right, let's get to this nasty here. So I showed you what this is. Here I have some water. This is no tricks. We just took this out of the faucet here, and I'm gonna spoon up some of this. And I'm gonna get as much as I can on the spoon here. Get a good nasty bit. There we go. We're gonna put this in here. Okay. And that looks terrible. Looks like your water jet tank. Looks like your trenches. Looks like nasty. There's a little bit of everything in here. We've got fines from polishing. We've got large particles from sawing. A little bit of everything. Let's do 2 of these so we can have some comparison. There we go. So we kind of treat this like our control for now. Ish. I will not be drinking this at the end. All right. So, what this is representative of, step 1. Nothing's been done to it. It's come off your machine, rolled across the floor, picked up some earplugs and razor blades, and it's made its way in there. So let's get to treating it. And I'm going to do coagulant chemistry first. Let's bring our control over. One thing I want to note here is I've had these in here for, I don't know, 25 seconds, maybe 30 seconds, and note how they look right now. Okay, they're nasty. In here so that you can see. Now what's noteworthy about this is there's a very bright light behind there, and we really don't have much really not have much transparency through them, so this is bad. So I'm gonna start mixing these, and I'm gonna rigorously mix them. And what this is simulating here is coming up out of our pump pit, turbulent flow inside this pipe. And we're going to do this step first. Okay? What I'm going to do is I'm going to introduce 6 parts per million of coagulant. Joe, say, why 6 parts per million?
Why 6 parts per million, Matt?
Glad you asked, Joe. We've worked with some chemists over the years, and this coagulant, this flocculant is unique to the stone industry. This isn't something that you're going to buy at any hardware store. It is unique. It is optimized for stone slurry. We're going to see that.
Hey, Matt.
Yeah.
Just to be clear, that is diluted, just like on the injection tanks would be, right?
Aha! I'm glad you mentioned that. Remember how I said that was one of the things I told you why we write on those tanks. We're going to write down what the chemical is and what its dilution factor is, because what you don't want to do, and this is for who asked that question earlier, why does one system perform than the other? The first question that our service team is going to ask you is, what did you mix your chemicals at? The ratio is 20-to-1 for coagulant and flocculant. We do that on purpose so that you don't get them mixed up back and forth. But I've seen it not a million times. I've seen it 16 times where someone in the shop says, "Hey, we're out of coagulant. Somebody go fill that up." And Daryl, Travis, or Bob goes over and he just dumps that pure chemistry in there when it needs to be diluted 20 to 1. That would definitely degrade one system over the other. All right, so let's make sure we have this correct. We're going to put in 6 parts per million side of here. Okay, there we go.
So correct me if you're wrong, if I'm wrong here, Matt, but you just simulated this injection nozzle, the very first one.
That's exactly right. That's exactly right. So now we've injected coagulant and we're having turbulent flow, turbulent flow, turbulent flow all the way through this pipe. So this is your turbulent flow right here. So what we're going to do is we're going to shut this down right now. Let's say it's made its way into the chamber. Let's shut this off. And I want to help you guys train your eyes here, because you can do this in your shop. You'll notice that these look very fuzzy, and you can start to see in the water column here, you can see the top becoming much more transparent. I think we've had about 6, 7, 8 seconds elapse since we dosed that.
Craig, here's the control also. You can see there's definitely a graininess and difference in the particles.
You can see some of the real coarse solids settle out, but you can see the fines are not settling out. What I want people to notice here is that these little flocks, the flocks that are in here, they are settling out. And you can see that they are, even as it's cloudy here, they are large. And you'll notice that if you take a sample in your shop, you'll notice that they look fuzzy. That's that flocculation happening that I was talking about, or not flocculation. That's that coagulant that I was talking about here. They're joining together, and the polymer in there is starting to make them look fluffy and larger. So they're heavier. They're heavier. Look at the difference that we've had here. Now we've had about 30 seconds. Okay. And this water is looking exceptional. I would have no problem sending that to my saw. Actually, that's getting close to polisher quality there. This, on the other hand, I probably would.
Hey, Matt, real quick, back to our question. The gentleman asked, would adding flocculant help them? And maybe, just maybe, I'll give you a minute when you get to the flocculant experiment, you can answer that. But be thinking about that question.
Sure.
As we move forward.
Sure. All right. So let's do another. Let's add in flocculant here, just for fun. Let's say. So we're going to agitate this, which isn't the greatest practice, but we're going to agitate this again. We're going to pick it up out of suspension, and we are going to dose this. Make sure I'm not getting these mixed up. Oh, very good, thank you. So let's get these mixing up again here. Now we're back to nasty again, and I'm going to simulate a little bit more of the flocculation chamber. We're going to do a gentle stir here. And this time I'm going to add 4 parts per million of flocculant to this. Your setup should be the same.
And again, Matt, that would be this second injection nozzle up here.
That's right. That's right. So what makes flocculant work is gentle. I've stirred this probably a bit too much. That's okay, but now come in here, Craig. Look how much larger. Look at how huge those big, beautiful flocks are. And look how rapidly it settled out. That settled out in about, we're not past, I bet that's 10 seconds. That is dramatic. And look at our control. Okay? That makes a water nerd really happy. Now, here's what I want you guys to see, and Craig, I hope you can see this. We look across this base here. Look at how fluffy that looks. It looks like the silt on the bottom of a lake. It looks fluffy. It looks larger. The flocks look large. And look at the very top of the water column. Look how clear that is. as we stand here and talk more, these are gonna continue to settle, just like what's happening in our clarifier there. Same thing. Meanwhile, this guy looks pretty nasty. So, Joe, let's talk about the flocculant and the system that someone was troubleshooting there. So for those, if anybody just joined us, there was a question a little bit ago about, would flocculant help someone who has two systems? Because one system is performing, if I understood correctly, and the other one was falling behind. No, to answer your question, the flocculant is not going to help steady one out over the other. I would be more concerned if they indeed are equivalent systems, if they are the same size, same capacity. I would be working towards getting them more even. I'm going to take a wild guess that the older system is not performing like the old or like the new, and a big part of that. The reason that I say that is because when we clean these, we need to make sure that we're doing a good job in getting into all the nooks and crannies, because what we can't have happen is have turbulent flow inside this clarifier plate pack here. What happens inside this pack all too often is we end up getting a pile of sludge down here that somebody didn't get cleaned out, and what that does, this is supposed to be a nice even flow through here. This is supposed to just be a nice flow. When you get a big clump down in one of these plate packs, or it accumulates on the sides, now you've got turbulent flow. You're not creating a laminar flow that the particles can settle out like we witnessed there. So that would be the very first thing that I look. No, that'd be the second thing I mentioned earlier. I'd be looking at chemical dosage. I would also go to the, let's go over here. I would also go to the line on the machine that is problematic. And I would pull this ferrule off, just a nut, and that comes off, and I would look. I would have my system running. I would see that this is actually dosing, because this is a peristaltic pump here, and there's a little rubber tube in there. And over time, that can degrade if the system's sat idle for a period of time. That's something that's easy to replace. This comes apart. You pop in a new tube. They're available from the service group. We do that not frequently, but it's common to do that. So check your line. Make sure that you actually have chemicals.
Matt, while you're back there, is there any other like real simple things to check? Maybe not even related to the question that was asked. Any other items that you would just make note of? You know, good practice. The first 2-3 things that you would look at if you're having issues.
Yeah, absolutely. So the first thing that we want to check is I can just go right down the line. I mean, this whole system follows a process line. So we have a repress pump in the pit here, and flow through the whole system. We also control via throttling valve the flow through the system. My point here is to check on what your system flow actually is, because if it's much too high, we'll want to turn it down a little bit, because your chemistry is dosed to that flow rate, and the system works optimally under that flow rate. So if you have let's go back up to the table because my knees hurt. If you have a small system that has a 1 horsepower slurry pump, you are pumping 50 gallons a minute unrestricted. Now, if you have a 1.5 horsepower slurry system, this would be the larger systems like our 100, you can pump up to about 95 gallons a minute. If that slurry pump is degrading, if you've got a t-shirt, an earplug, or a razor blade stuck in the impeller of that, which happens all the time, then you're not gonna have that flow rate, and so you're not matching the system to get optimal settling out. So keep firing off the questions at me as we go here. But while I'm babbling, I want you guys to look at this water again, because there's 2 things that I want to tell you. Number 1, this does not look turbid to me at all. Number 2, I don't have anything floating There's nothing floating at the very top here. Okay. What that tells me is that I have properly dosed the coagulant and the flocculant. I didn't just luck out there. I knew that was the way to go. But there's two things that I want people to look at when they're looking at a water sample that they can take right out of their transfer tank. So, today, if you're interested, go out there, take a sample out of your transfer tank, and just watch it. Take it like this. Just watch it. Pay attention to if anything's settled out. If anything's settled out in the bottom, a little bit is okay, a little fuzz. But if you have anything that looks like this, where the entire bottom of your water sample is coated, we need to do something. And that can be slowing down the flow rate. It can be your chemicals. It can be any number of things. But it should put you into action. Is what my point is. So let me tell you how I know something is overdosed. Let's go back over to the theory here. Overdosing isn't as easy to correct as underdosing, and here's why. So when we overdose, you'll remember that I changed all of these in a coagulant setting. I've changed all of these to neutral so that they can bump into each other. If I overdose, I can take these from a negative charge all the way to a positive charge, and now you're back to repulsion, and that's going to keep things suspended in the water column. So if I still saw cloudy, turbid, nasty, still suspended, I could suspect an overdose, and I'd want to adjust my my coagulant right away and my flocculant. In fact, when all things point to overdose, our service team is going to tell you, shut it down, watch for that improvement. And that's when you need to be taking those water samples and looking at them in a column of water, looking at it going, that worked, that's doing better. And so once you train your eye for what that's supposed to look like, you can correct a problem like that pretty easily. Yeah.
Very good. Well, thank you, Matt, for all of this insight, knowledge you've shared with us today. Again, if there's any questions, put it in the comments. Even if we don't catch it while we're live, we'll get back to you. Another thing to put in the comments is, what do you want to see next? This one came from a viewer, this segment here. Felt like it was a pretty good segment. I learned a lot, and hopefully you did too. But again, if you have great ideas, put them in the comments. We'd love to do them. Thank you. Have a great day.
One more question.
Oh, one more question.
Keep them rolling.
Yes. What do we got? Older system outperforming the new system. We dump the pressure and wash every 6 months. Could it be that we are using the water so quick it doesn't have a chance to settle?
That is quite possible. And I'm happy that you brought that up, because it just reminded me of something. Okay, so let's talk about that. A little bit ago, I was talking about how fast slurry pumps are pumping and what they're supposed to be pumping out. If you are pumping too quickly through your system, it's going to be too turbulent inside there, and you're not going to promote settling inside there. So what we do, and here's a quick thing that you can do, and this is what I would do. I would go and I would take a water sample right now before you touch anything. Then I would come over to your system, and I would throttle your flow into the clarifier. I would slow it down, and then go back up and take that sample again, entering your tank here. See if you notice any improvement. Again, depending on the size of your system, let's see, 80s and 90s were most popular systems. So a HydroClear 80, pretty optimal operation between 30 and 40 GPM. You could actually take a 5-gallon bucket up to the top and take a look and measure to see if that's what's coming out of there, or you might be pumping 10 gallons a minute out of there. A 90 system optimally is right around between 50 and 80. If we get too far above 80, we end up just shooting solids through. Now, let me know if there's a question that follows up to that. But the reason that I thought that this was important is because we have a lot of customers that will put a clarifier system in front of a filter press with dramatic results. They go from cleaning a filter press every 3 days to every 3 weeks. It's amazing. The issue that we run into there is that the clarifiers they're actually capable of getting that water too clean for the filter presses, and we end up blinding the plate pack. So when our installers or the application engineer fits that system to you, that's one of our criteria. We need to know if you're doing that, because we will purposely send a little bit dirtier water through that clarifier. And the way that we do that is by speeding up the water in the clarifier so that some of those solids pass through. Now, another point that I wanted to make is that we hear filter press manufacturers, they say, oh, no chemicals, it doesn't work, we can't do that. I would contradict that and state that very little bit of chemical that we put in front of that actually helps that filter press perform a little bit better. It doesn't blind the plates. We introduce those large flocks into the press, and we don't see those claims as we don't see those in the field. So I was hoping we'd have a few questions about filter press. That's a pretty common application. You got any more questions on the horn? Come on, stump me. Okay.
Well,
all right.
Again, if you do have any more questions, put them in the comments. If you can get them in quick before we close out of this, we'll turn them over to Matt. If not, we'll answer them offline and get back to you through the comments section. Thank you for your time. We enjoyed this, and have a great day. See you in 2 weeks.
Let's just watch this a bit.